Our focus for tonight is on solving systems of equations. Now, a couple of things that we need to remember when dealing with the substitution method. First, it's helpful for us to have one of our variables isolated. That's the whole point of substitution, is we know that that individual variable by itself is equal to some expression. So we can substitute in that expression anytime we see that variable y. And so, as we saw in class, what I'm going to do is I'm going to circle the place where my variable is being repeated, and I'm going to box in what I'm choosing to substitute. Now, since I'm substituting x plus 4 for my value of y, then I'm going to rewrite this entire second equation, 2x plus y, whatever y is. In this case, we're stating that y is going to be x plus 4 equals 19. And now we know from our from our solving equations unit, we have 3 steps for solving equations. First, distribute. Second, combine like terms. And then third, isolate your variables using SADMAP. So we're going to distribute. Since we're distributing a positive 1, it's simply going to clear our parentheses. 2x plus 4 equals 19. 2x plus x is 3x. Plus 4 equals 19. So we distributed. We combined like terms. Now we're working on isolating our variable. So I'll subtract 4 from both sides. 3x equals 15 divided by 3. X equals 5. Now, it's great to know the value of x, but knowing the value of x alone is not solving a system. We need to know the value of x and its y. So I'm going to go ahead and take my easier equation here and say that y is equal to, now my value of x, which is 5, plus 4. So y must be 9. So we have an x value of 5, we have a y value of 9, and we're at the point where we can start checking our equation. Or start checking our solution. So we'll plug in my y value of 9 equals my x value of 5 plus 4. Well, 5 plus 4 equals 9. So we end up with 9 equaling 9, which is a true statement. We check it and move on to the next equation. 2 times x, well, x we determined to be 5, plus y, which we determined to be 9, is equal to 19. Now we need to follow our order of operations. 2 times 5 is 10, plus 9 equals 19. 10 plus 9 is 19, which equals 19. And we check it because we did everything correct. Problem number 2. Actually, I'm going to jump down to problem number 4. Because we spent most of the day solving for y, aside from the fact that I gave you several other variables in class. Because we can isolate any variable. It doesn't matter which variable we isolate. Here I have a x plus 2y, where my x has a coefficient of 1, so it's going to be simplest to isolate the x value. So x plus 2y equals 1. I will subtract 2y from both sides. So x then equals negative 2y plus 1. All we've done thus far is manipulate this equation so that we have x by itself. Now, since I see that x is the same as x, I'm going to substitute in the value of x. So we end up with 5 times x, which we have said now is negative 2y plus 1, plus 3y equals negative 23. Again, our steps for solving an equation: we distribute, we combine like terms, we isolate the variable. So I'll distribute. 5 times negative 2y is negative 10y. 5 times 1 is 5, plus 3y equals negative 23. Combine our like terms. Negative 10 and 3y gives us negative 7y plus 5 equals negative 23. We'll isolate our variable, which means we want to work order of operations backwards. So I'm going to subtract 5. Negative 23 minus 5, negative 28. And then we're going to divide by negative 7, where y will equal 4. Now, yes, that is a decent amount of work for one problem, and we're not even done yet, because all we've done so far is identify the value of y. We still need to plug that value in for y so that we can find the x value. So we have x plus 2 times my y value of 4 equals 1. 2 times 4 is 8. We will subtract 8 from both sides, and x is going to equal negative 7. So our ordered pair for this set of equations is negative 7, 4. And we're going to do good math by checking our solutions. Our x value, negative 7, plus 2 times our y value, which is 4, equals 1. 2 times 4 is 8. Negative 7 plus 8 equals 1. We know negative 7 plus 8, they are opposite, positive and a negative, so we'll find the difference. Keep the sign of the larger value. 8's the larger value, so we're going to keep its sign. The difference is 1. 1 equals 1. That checks out. Well, now we want to check the other equation. 5 times negative 7 plus 3 times 4 equals negative 23. 5 times negative 7 is negative 35. 3 times 4 is 12 equals negative 23. Negative and a positive again. Find the difference between the two, which is 23. Keep the sign in the larger absolute value number, which is the negative 35, equals negative 23. They do, in fact, equal each other, so we check. This ordered pair satisfied both equations, so that would be a point in which they intersect. Let's look at number 9, because for this particular problem, we don't have a variable that is isolated or sitting by itself. So, in order to solve the problem, we're going to have to get a variable by itself. So I'm going to start with that equation. You could certainly start with the other. It doesn't particularly matter. I'm going to go ahead and isolate from my y. Negative 2y equals negative 3x plus 10. And I'll divide by negative 2. Y is equal to, let's see, that makes that positive 3 halves x minus 5. So we now know the value of y. I can circle the y there, and I can circle the y there. That's where I'm going to substitute in my value of y. We've determined our actual value of y to be 3/2 x minus 5, and I'm going to plug that in right there. So that leaves me with 5x plus 3 times whatever my value of y is, which we just said was 3/2 x minus 5. All of that will equal 4. So again, my order steps, we're going to distribute, combine like terms, isolate the variable. 5x plus 3 times 3 is 9, so that's going to give me 9 halves x. Three times -5, -15 equals 4. I will add 15 to both sides, where 19 is equal to, remember that 5 is the same as 10 over 2. I'm going to go ahead and cross through that and say 10 over 2 so that I can add these fractions together, which gives me 19 over 2x equaling 19. In order to clear that coefficient, we're going to multiply by its reciprocal, 2 over 19. That will simplify out, and that drops x down by itself. Remember that what you do to one side of the equation, you have to do the other, so we're going to multiply by 2 over 19, which means that will simplify out. We're left with x equaling 2. Well, now that I know the value of x, we've done a lot of work to get to it. We plug that value of x into either equation. It doesn't really matter. So 3 times 2, I'm using this top equation, minus 2y equals 10. 3 times 2 is 6, minus 2y equals 10. We will subtract 6 from both sides. 4 equals -2y. And we're going to divide both sides by -2, so y is equal to -2. After a decent amount of work, we've determined that we have an ordered pair of 2, -2, that satisfies this system of equations. Again, you're going to want to check your solutions. 3 times 2 minus 2 times -2 equals 10. 3 times 2 is 6, minus 2 times -2 is -4, so that's going to become positive, equals 10. 6 plus 4 is 10 equals 10. That checks out. Checking the next equation, 5 times 2 plus 3 times the y value of -2 is equal to 4. 5 times 2 is 10, plus 3 times 2 is, 3 times -2 is -6, equals 4. 10 minus 6 is 4, equals 4. That also checks out.